Hey peeps, it's Sophie here with Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with the Physical Science 2018 Grade 12 paper, and this is question 11. Okay, so it's given us that the threshold frequencies of calcium and potassium metals are given in the table below. Okay, so they're calcium, potassium, and their threshold frequencies, F0. Then 11.1 says define the term work function in words. So I put that in the green sticky note, and it is the minimum energy needed to eject an electron from a metal surface. Okay, 11.2 says which one of the two metals in the table has a higher work function. Okay, so we know that work function is directly linked to threshold frequency. So let's just write this here. And we know that the potassium threshold frequency is higher than the calcium threshold frequency. So I'm just going to write F0 of potassium is greater than F0 of calcium. So that means that the potassium has a higher work function. Okay. So then it says the simplified diagrams below show two circuits, A and B, containing photocells. The photocell in circuit A contains a calcium metal plate, while the photocell in circuit B contains a potassium metal plate. Okay. Ultraviolet light with the same intensity and wavelength of 5.5 times 10 to the minus 7 meters is incident on the metal plate in each of the photocells, and the ammeter in circuit A registers a current. By means of a calculation, determine whether the ammeter in circuit B will also register a current. Okay, so we can work this out by working out kind of the minimum frequency that, well, the frequency of this light, of this ultraviolet light, compared to the threshold frequency of potassium. Okay. So that we can use this formula for. C is equal to frequency times wavelength. And we know that the speed of light, is 3 times 10 to the 8. Frequency we know is, well, we don't know actually, we know the wavelength. We know the wavelength is 5.5 times 10 to the minus 7. So we can get our frequency to be 5.45 times 10 to the 14 hertz. Okay, we can see that that is lower than the threshold frequency of potassium. So we know so therefore the frequency of UV is lower than the threshold frequency of potassium. So that means that the ammeter cannot show a reading because it's not at that threshold frequency that's required. Okay. So the threshold frequency is the minimum frequency of light that it can read, that photocell can read. Okay, so 11.4, it says calculate the maximum kinetic energy of an ejected electron in circuit A. Okay, so for that, we will need this formula here. So we know that Planck's constant, C over lambda, is equal to Planck's constant threshold frequency plus EK max, which is the maximum kinetic energy. Okay. So let's go for it. So we know that Planck's constant is 6.63 times 10 to the minus 34 times 3 times 10 to the 8, which is C, over 5.5 times 10 to the minus 7, which was given. And then that is equal to, I'm going to move on to the next line here, 6.63 times 10 to the minus 34 again, times 5.07 times 10 to the 14, plus EK max. Okay, and then from there we can get your kinetic energy is equal to 2.55 times 10 to the minus 20 joules. Okay, so that's the energy ejected by the electron in circuit A. Okay, then 11.5 says how will the maximum kinetic energy of the ejected electron calculated in 11.4 change when the intensity of incident light increases? Okay, so we know that the intensity of light doesn't change the kinetic energy. So it's going to remain the same. Okay, so that's it for this question. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. Also be sure to visit our website for more of these epic tutorial videos, and if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until the next time, stay epic.